All right, guys, so I was asked to share again the idea of a ball bouncing off of a wooden block versus not bouncing. All right, so on the left, we have a ball that's bouncing. Okay, so we're going to draw a table just like we did before. Okay, so we've got the initial and the final momentums. And then we've got the ball, and we've got the block. Okay, and same thing with the no bounce. All right, we'll look at the initial and the final, and then we'll look at the ball, and we'll look at the block. Okay, so first let's look at the initial. So initially, the ball has a mass of m, and a velocity of v, flying towards, or to the right, we'll say. All right. The block, of course, is not moving, so it has a momentum of 0. All right. Now, if we add those together, then we get a total momentum of mv. Now, of course, what that means is that the final momentum needs to be mv. Now, this is, of course, assuming that we're looking right before it hits the wall and right after it hits the wall, right? So there's not really enough time for gravity to cause a serious change in the speed, just instantaneously before the hit and then right after the hit. That's our initial and final points. So the final, of course, has to still be mv. But now let's look at the mass and the velocity of the ball once it bounces off. Now, we agreed in class that the speed was probably about half of what it was. Okay, it was losing a significant amount of its energy as it bounced off the ground. We noticed that it went to about half of the height. We could do some more specific conservation of energy to find out a little bit more with the speed, but I think we're okay just saying that it's about half of the speed that it was before. So the final momentum of the ball would be its mass times half of the original velocity, but it's also to the left, and so we need to say that it's negative. All right, and then of course what we're trying to find here is the momentum of the block. All right, so what we can do is we can say the momentum final of the block plus negative 1/2 mv is equal to mv. So that's what I'm doing. I'm adding together the final momentums, and it needs to equal mv because momentum's being conserved, right? And so what we can find here is that if I add the 1/2 mv to the other side, then what I get is that the final momentum is equal to mv plus 1/2 mv, which would be 3/2 mv. So that would be my final momentum if the ball bounces back with half the speed that it had before. Okay, now this should make sense because the ball was moving to the right with a certain amount of momentum. It loses all of that momentum and then gains momentum in the opposite direction, which means you have quite a significant change in momentum. Whatever happens to the ball, the opposite needs to happen to the block. It needs to gain that much momentum to the right. Now let's see if we can do the same thing with the no bounce, right? The ball has an initial momentum of mv. The block has an initial momentum of 0. So you add those together. Again, we get mv. So the final is mv. But in the situation where the ball doesn't bounce, it kind of flies and hits it, and then it stops and falls. So we'll say before it starts falling that the final momentum of the ball is 0. It might be slightly more than that, but for the most part it's 0. So same thing as before, we're going to find the final momentum. And when we do that, we're going to go 0 plus final momentum equals mv. And of course, that means that the final momentum of the block is going to be mv. And so what we see is that when the ball bounces, there's a larger change in momentum for the ball, and so therefore a larger change in momentum for the block. There you go.